In this lesson, I'll show you how to solve a system by inversing a matrix. Let's start with a bit of theory. If A times x is equal to B has a unique solution, then the matrix X is equal to the inverse of matrix A times B. To solve a linear system of equations, we multiply the inverse of A and B to find X. Given what you see above, the matrix is abbreviated AX is equal to B, where A is the coefficient matrix of the system, and X and B are matrices containing one column. These are called column matrices. Matrix B is called the constant matrix. That being said, the question reads, solve the system using the inverse of a matrix. The first thing that I'll do is write out the leading coefficients of the variables as their own matrix. For example, take equation 1. We have x plus 2z. That can be written as 1, 0, and 2, where 0 represents the coefficient of y. It doesn't exist, so we replace it with a 0. For the second equation, you have negative 1, 2, and 3. And lastly, you have 1, negative 1, 0. This is called matrix A, and it's currently being multiplied to matrix X, which houses the letters x, y, and z. And this is equal to the constants, 6, negative 5, and 6. Now, I have to find the inverse of A, and that's the hard part. I need to convert A as its identity matrix, and an identity matrix is one that is 3 by 3 in this case, and it will have ones along the main diagonal with zeros above and below those ones. Let me show you what I mean. The identity matrix for A will be 1, 1, and 1 in the main diagonal, and zeros above and below. And what I have to do is make this matrix, through row operations, look like its identity. Now normally this takes a while to do, so I'll try to do it as fast as I can for you, and I'll document my steps. The first thing that I'll do is make this negative 1 into a 0, and then subsequently make this 1 underneath it into a 0. Let's go ahead and do that. To make this negative 1 into a 0, I can take all of row 1 and add it to row 2. So row 1 plus row 2. And the answers that I get here will replace row 2. 1 plus negative 1 is equal to 0. 0 plus 2 is 2. 2 plus 3 is 5. 1 plus 0 is 1. That remains 1, and that remains 0. So our brand new row 2 should have the following numbers. Next, I want to make this 1 into a 0, and I can do that by saying row 1 minus row 3. 1 minus 1 is 0. 0 minus negative 1, that's positive 1. 2 minus 0 is 2. 1, 0, and this becomes negative 1. Our brand new row 2 should look like this. My next step is to make this 2 into a 1. Remember, we want our main diagonal as 1s. I can do this by switching row 3 with row 2. If you do that, you should have a matrix that looks like this. My next step is to make this 2 into a 0, and I can do that by multiplying all of row 2 by 2 and subtracting from row 3. Multiplying this by 2, I get 2 minus 2 is 0. 4 minus 5 is negative 1. 2 times 1 is 2, minus 1 is 1. 2 times 0 is 0, minus 1 is negative 1. 2 times negative 1 is negative 2, minus 0 is negative 2. Row 3 should now look like this. Now, we have to make this negative 1 into a positive 1, and I can do that by multiplying all of row 3 by a factor of negative 1. That makes this positive, negative, positive, and positive. The final two things that we have to do is make these two 2's into zeros. Starting with this 2, I can multiply all of row 3 by 2, and then subtract it from row 2. Starting with this 0, 0 times 2 is 0, minus 1 is negative 1, 2 times 1 is 2, minus 2 is 0. Here we get negative 2, subtracting that from 1, that's negative 3. 2 times 1 is 2, minus 0 is 2. 4 minus negative 1 is 5. Now we have a negative 1 that can be removed by multiplying all of row 2 by a factor of negative 1. This becomes positive, this becomes positive, negative, and negative. Lastly, we want to make this 2 into a 0. And once again, we can multiply all of row 3 by a factor of, let's say this time, negative 2. And add it to row 1. This remains the way it is. This becomes negative 2 plus 2, that's 0. Negative 1 times negative 2, that's positive 2. This makes it 3. Negative 2 plus 0 is negative 2. And lastly, the product of 2 and negative 2 is negative 4 plus 0 is negative 4. Our matrix should look like this. The matrix that you see right here is the inverse of matrix A. And what we do next is multiply this matrix with B. And by doing that, you should end up with your variables x, y, and z. Let's start with x. Using our calculator, we have 3 times 6 plus negative 2 times negative 5 plus negative 4 times positive 6. You should end up with 4. And if you do the same thing for row 2 in this column vector and row 3 in this column vector, you should end up with the following y and z values: negative 2 and positive 1. Therefore, your solution here is 4, negative 2, and positive 1. There you have it. That is how to solve a system by inversing a matrix.